Okay, so let us start this session. So, previous classes we have discussed about alternating quantities, water, AC, alternating quantity, alternating current, alternating voltage. We have also discussed about the calculation of the like peak value, average value, RMS values, all these things we have done. So today we'll move forward with the next concept of phasor diagram. After we discuss phasor diagram, then we will go to the three fundamental AC circuits. That means purely resistive, purely inductive, purely capacitive. After that, LCR series circuit, which is the most important topic of this chapter. Most of the questions in NEET or JEE or any competitive exams will come from that. Okay. After that, eddy current, and last topic is transformer. Then with this we wind up. Okay, so let's see how many we will cover today. Let's start with the phasor diagram. Phasor diagram. Phasor diagram. Phasor diagram. So what is phasor diagram? Phasor diagram is like it is used to represent sinusoidal functions. Like we know V equal to V naught sine omega t. This is sinusoidal function. Okay, so it can be represented by a vector like this V naught. So you can try to make a circle like this. You make a circle. Okay, and the radius of this circle is V naught, and this is the center of this circle O. And let us say that this is x-axis and this is y-axis. If you want, you can draw, otherwise leave it. Okay. So y-axis, x-axis is important because the angle is measured from here. So at a given angle or given time, let us say it is making angle omega t. Omega t. We are assuming that initially this vector was, this is called rotating vector. Initially this radius vector was here. Okay. Initially. So time 0, we assume that time 0, this is the position. And because this is rotating with the angular velocity omega, so this is the theta. Theta is equal to omega t, you know. Omega is equal to theta by t. So theta is equal to omega into t. So in a time interval at a given time t, it has rotated from here to here. This is the initial position and this vector is rotating. So gradually this is rotating. So phasor is a rotating vector. Phasor is a rotating vector. But then you will ask that we want V naught sine theta, but what to do with V naught? V naught means this is the radius of this circle and this is rotating. So what to do with V naught only? So V naught is representing the peak value, that we know that, right? So now suppose if I drop a perpendicular here, suppose if I drop a perpendicular here. So what is this perpendicular? You know that this distance is V naught. So this is V naught cos theta, this is V naught sin theta. So now comes the V naught sin theta term. So this V naught sin theta term, that is what it is, this one. This is the perpendicular component of this vector. So perpendicular component of this vector, which is V naught sin theta, that is what we are interested in, right? So as the angle changes, this V naught sin omega t, theta is omega t, so let us write that. So as the angle changes, this term will also change, right? This term will change. So we can understand this. Let us say time 0 is there. So sinusoidal graph, you know, you can plot the sinusoidal graph. And note that this is the circle, means you can take like this. Okay, like this. One cycle it is like that. So what is one cycle means? This is the maximum value of this circle, right? Maximum value means this one, this. And similarly this minimum value is this one. So correspondingly together you can draw this phasor diagram and graph together you can plot. Okay. So suppose the vector is here. So if you see the value V naught sine theta sine 0 is 0, that means it will be starting from here. Okay. Now suppose at any instant it is here, this phasor is here, so its tip or the topmost point you try to drop here. So that means right now this is the point on the graph. Now when it has come here, suppose the phasor has rotated and come 90 degrees. So at that instant, this has got the maximum value. Okay. Then suppose the phasor is rotating and let us say it has come here. Then at that time, this again y is becoming 0, right? Again y will become 0. So you will see that it has become 0 here. Okay. Then again it is rotating and it has come like this, let us say downward. So then it has come here. Maximum it has gone this point. Again when this factor rotates and come back to the same position over one cycle, then this point you have to draw now again this, right? Because it has completed now one full cycle. So this has started 90-degree rotated, 180-degree, 270, then 360-degree. The 360-degree rotation of this creates one complete cycle of sinusoidal function. So side by side we can draw this graph and we can see how the graph is going. So basically the top of this point, the tip of this arrow, how the tip is moving, that is what we are showing here. And we are showing the vertical component, not that tip is moving like a circle, but the vertical component graph, that is V naught sine theta graph, okay, with respect to time. So that's a phasor diagram, very important concept. And note that this angle theta is called phase angle. Okay. So if I represent this phasor as V equal to V naught sine omega t, this omega t angle, omega t or this angle theta, that is called phase angle. Phase angle. And the term omega, which is 2 pi by time period or 2 pi into frequency, this is called angular frequency. Angular frequency. F is called linear frequency. F is called linear frequency. Okay. And this linear frequency F, that linear frequency F is equal to 1 by time period. Okay. The unit of frequency, this unit of frequency is in hertz, right? And the unit of angular frequency unit is radian per second. Okay. Radian. This is SI unit. Okay. Frequency can also be sometimes written as number of cycles per second. So suppose n number of cycles are happening. Total number of cycles is happening n, and that total cycle is happening in time t second. So that is also called frequency. Sometimes this frequency can also be written as differentiation dn by dt. Because if frequency is not constant, then you have to differentiate the number of cycles with time. Right? So dn by dt also it is called. But anyway, it is going with a constant speed, right? We are assuming that it is going with a constant speed. So if it is going with a constant speed, then let us say if I put one cycle, then that time is capital T. That is the time period for one cycle. If you take two cycles, then it will be 2 capital T. So anyway, this ratio will come as 1 by T only, right? If it is going with a constant speed, it will not matter otherwise. Okay. Clear. So this is how these are the important terms here, feature diagram. Now let us go into the concept of AC circuit. There are three basic AC circuit. We will go one by one, and if you got this idea, then you can solve any complex level question or any easy question also. Okay. So let us go into the concept of AC circuit. AC circuit. AC circuit. So first circuit is purely resistive AC circuit. Purely resistive AC circuit. So what happens? This AC signal is represented by this symbol V equal to V naught sin omega t, and this is connected to a resistor. This resistor has resistance R. And this point is, let us say, point A, point B. Okay. In between them, we have connected it. So now suppose if I apply KVL in this loop, that means let us say that an instant of time this is positive and this is negative. So current is going like this. Okay. Current is going like this. This is the current I. Let us apply Kirchhoff's voltage rule. We can write directly also, but it's better to learn the approach, because in complex question that approach only will help us. Okay. So let us go in this loop A to B. You know that when you are going in this direction of current, the voltage decreases, so change of potential will be minus IR. Then you are coming from minus to plus, so this is plus V is equal to 0. That means V equal to IR. I is equal to V by R. But V is not constant, V is changing. So that is V naught sine omega t divided by R. Okay, so the current I, V naught by R can be written as I naught sine omega t. That's how it is. Okay, so I is equal to I naught sine omega t. So if you see the voltage, V voltage is also like this. Here what is I naught? I naught is the V naught by R. I naught is where I naught is V naught by R. Okay. So this is the peak value of current, which is equal to peak value of voltage divided by resistance. So definitely current is also changing, and all AC circuits we are going to do this only. What is the purpose? We are applying AC voltage, right? We are applying AC voltage, but what is the purpose? The purpose is to calculate current, how current changes with time, and how current and voltage phasor diagram looks like, so that we can calculate the phase difference. Phase difference means angle difference. This angle is omega t here, and this is sine also. That is also sine, and this is also omega t. So both should be same trigonometric ratio, sine sine or cos cos. And angles are different means there is a difference in the angle. But here angle is same, so there is no phase difference. There is no phase difference. Now let us draw here the phasor diagram. Suppose if I draw phasor diagram. So first I will draw the voltage phasor. Voltage phasor we are drawing. So at an instant, voltage phasor is at angle omega t. Right. So if you want, you can draw a circle. As I told, we can draw a circle like this. We can draw a circle, and current will also be in the same direction. So that will be current phasor, right? And this circle you can draw smaller or bigger circle, whatever, but different radius. Let us draw. So this I naught is nothing but the amplitude of current, and V naught is also the amplitude of voltage, right? And you can note that both of them are at the same angle omega t. So at a given instant, both the factors are pointing in the same direction. That means together they will rotate. Together they will rotate. They will not rotate different. Of course, their angular speeds are same, but there is no difference in their angle. They are always at the same angular position. Okay, so they are going to rotate together. So that is what it is, phasor diagram. Now suppose I want to draw the graph. Okay, so what I will do, I will take this as time, and this I will take as y-axis, let us draw this voltage phasor first. So we already know this in board exam, very important, because they will ask to draw this graph. This is V naught and this lowest point minus V naught. Okay, so the graph of this voltage phasor should lie between minus V naught and plus V naught. Let us draw that sinusoidal, right? So it is going to be a sinusoidal function. We can draw this. This is one cycle we have drawn. Okay, one cycle of voltage we have drawn. Now let us draw this for current. Current also you can draw this line. Similarly, this line also you can draw. This line represent plus I naught and this represent minus I naught. Note that the same y-axis is used to represent two different quantities, okay, depending on what you are studying. So first time we are representing voltage, next time now we are making current. So current graph will be looking exactly in the same manner. Together they go and together they fall. Okay, together. So this is what the current and voltage graph will look like. So this graph is current graph and the upper graph is the voltage graph. So together they will reach the peak value. Together they will become zero. Together they started with zero value. Together they will get the minimum value. Together again they will complete cycle. Okay, so this is phasor diagram. This is the graph of the phasor diagram. And this graph is for purely resistive circuit. Clear? Okay, so what else we can do the calculation? Here we are going to do the calculation of this average power. Okay, let us also calculate average power. Let us do the calculation of average power. Before that, note some important things, that there is no phase difference. There is no phase difference. There is no phase difference between current and voltage. Current and voltage. There is no phase difference between current and voltage phasors. They are called phasors. Okay, no phase difference. Okay, they are always rotating together. Then, what is the average power? Let us calculate average power. So first of all, we know the power, instantaneous power is V into I. V is V naught sine omega t. I is I naught sine omega t. So power becomes V naught I naught sine square omega t. Now this is sine square. Sine square average we know how to calculate, but still let us do the calculation according to our formulas. So let us calculate average power. Integration of P dt 0 to t over one cycle. Okay, note that always over one cycle we will calculate. Over one cycle. One cycle time is t. So let us calculate this. V naught mean I naught constant, take out, integrate sine square omega t over one cycle 0 to t. So we know the integration, right? We have practiced it. Sine square integration 1 minus cos 2 theta, right? Divided by 2. Right? Remember, 1 minus cos 2 theta is 2 sine square theta by 2. That's what we have done. Integration limit is same 0 to t. Let us do this integration. So V naught sorry, V naught I naught by 2 I will take out. Then integrate 1. You can break this, but 1 integration we know it is t. Cos integration give us sine, and this 2 omega gets divided 0 to t. Let us substitute upper limit. So V naught I naught by 2 capital T upper limit t minus sine 2 omega t. We also know sine 2 omega capital T, okay, by 2 omega. Lower limit everything is 0. We know that omega t is 2 pi, that idea we already have, right? So 2 omega t will become 4 pi and sine 4 pi is also 0, that we know that. So now directly we will put that term as 0. This term is going to be 0 because sine of 4 omega. Okay. So finally we will get V naught I naught by 2t into t. So that's what we are getting as V naught I naught by 2. So this we have to remember, that the average power over one cycle is V naught I naught by 2, which can also be written as V naught by root 2 into I naught by root 2. This you know what it is called. What this is called? What is V naught by root 2? Yes, Sam. What is V naught by root 2? Remember? What is V naught by root 2? Forgotten. Hmm? Monis, you remember or not? Traveling outside. So you should remember. This is very basic thing. We have done calculation. Hmm? V naught by root 2, what it is called? No? Okay. VRMS. Forgot? I naught by root 2. IRMS. Hmm? Yeah. RMS. We have to remember. Okay. So, average power formula in a purely resistive circuit over one cycle is given by this formula. Okay, we have to remember this. Okay, done. So, and this average power means it is the rate at which heat is developed. Suppose they ask what is the rate at which heat is developed, because power means heat will be developed. So, this is the rate at which heat is developed. Clear? Done. Understood that, right? Okay, let us move to the now purely inductive circuit. Purely second circuit, very important second circuit, purely inductive circuit, AC circuit, purely inductive AC circuit. Now purely inductive circuit means this V equal to V naught sine omega t is there, and this is connected with the inductor. This inductor has inductance cell. Let us take this point as point A, this point is point B, and let us say this is plus minus, so current is going like this way. Again we are writing current direction. Okay, again apply KVL. You're going in this loop, apply KVL. KVL we apply. So A to B, when we are going A to B direction, that is minus L di by dt. I think you have remembered this. We have studied in electromagnetic induction. So here to here, you are going in the direction, right? Minus L di by dt. Then you are going from minus to plus, so that will become plus voltage. So from here, this voltage is equal to L di by dt. Okay, but this voltage V is what? V is V naught sine omega t is equal to L di by dt. Remember, we want to calculate current di, so di you bring this side. So this is V naught, right? L you bring this side. V naught by L sine omega t dt. Right? Okay. Now do the integration. Now do the integration. Time is 0 to t. But the thing is that current from where to where it is going, right? Current limits we do not know. But note that initially the current which is will be going, we have to take like a maximum current. Even in NCERT they have not explained this. Okay, they have done without the limits integration. So let's do without the limit. NCERT they have not explained this. I think they have not explained in many textbooks. We will see that. Okay, first let us do integration. Yes. Initially itself it will be maximum. That we will see afterward. But let us do the integration without limit. Okay, without limit. Let us do that. So this will give us I. Left side give I. Left side give this I. Right side this V naught by L constant. Sine integration we know it is minus cos omega t divided by omega. And some constant of integration you can add, some constant of integration. Okay, some constant of integration you can add. So in a, because it's a indefinite integration now, you remember, in indefinite integration we add a constant. Okay, and in definite integration you will substitute the limits, but we do not know limits, so we are doing indefinite integration. Okay, so if you consider this time 0, if you take time 0, then uh, this will become some value, right? Cos this, it will become minus, right? Cos 0 is here 1, so you will get some value, and that constant. Okay, so the thing is that they have not given in NCERT also, they have just taken this constant as 0. Okay, now we think about it. You read NCERT and find out why they have taken 0. I'll explain afterward. There is a reason why this constant is taken 0. Okay, so if you take this constant 0, this constant of integration is taken as 0. So if you take this as 0, then this formula you will get I is equal minus you take out, and this V naught by omega L cos omega t. Okay, and note that this V naught by omega L we can write as current I naught. So this we will write as minus I naught cos omega t. So this I naught here, where I naught is equal to V naught by omega L. Okay, omega L, and this current is like voltage by resistance. So that means what? That means this term omega L represent resistance. Definitely it must represent resistance. What kind of resistance is there? This is resistance of inductor in AC circuit. So we are calling this by a new name. We are going to call this as XL. Okay, XL. So XL is omega L. XL is called inductive reactance. Inductive reactance. which unit is same like resistance only. Okay. So yeah, that's what. So finally we can get this current equation we have got, right. So this current equation is minus I naught cos omega t. Now this can also be written as minus you take inside, okay. So this can be written as I naught um, sin omega t minus 90 degree, correct? 90 degree or pi by 2. So this is how we can write, because sin 90 minus theta is cos theta, but this is sin of minus 90 minus theta. Sin of minus 90 minus theta. So notice why it is taken like this, because sin of omega t minus 90 degree means it is equal to sin of minus 90 minus theta omega t, correct? Minus, okay. Now this minus will take out, because sin minus theta is minus sin theta. So minus comes out to sin 90 minus omega. That is why this is coming as cos, right? Minus cos omega. Okay, we getting this? Like this. That is why why are we writing in sine? The reason is that everything should be brought in terms of sine, so that we can compare with the voltage phase, because voltage is in terms of sine, we not sine omega t. So current should also be in terms of sine only. Suppose voltage is in cos, then everything should be brought in cos, because then only we can see the difference of the angle, right? Okay. Right, so that's done. Now here also we can try to draw the phasor diagram and the graph. Okay. Let us draw the phasor diagram. So this is our voltage phasor. So this will be the circuit of the voltage graph diagram circle, and current will be, you make some small circle. Let us see. This is the current circle. Okay. But the thing is that if you are representing this horizontal line and this angle we are taking as omega t. Now this omega t minus 90 degree means you have to subtract 90 from omega t from this side. So if you subtract, then it will be below 90 degree below, right? So here you will be drawing this current. So why are we doing it like this? So here you need to note that this angle, value of this angle will be 90 minus omega t only, because total angle is 90 degree, right? Total angle is 90 degree. But now see the direction. This direction is positive, means anti-clockwise. This is clockwise. Clockwise means negative. So the value of angle is 90 minus omega t only, but it is clockwise, so it is minus of 90 minus omega t, which is omega t minus 90. Okay, so from this, see, you note that this phasor V naught is making omega t. From omega t you subtract 90 degrees. So as you subtract, it will come back here. Okay, so that is why this is the current phasor. This is representing current phasor. Okay, right, and this angle is omega t minus 90 degree. Okay, now we want to draw the graph here, right? Graph also we want to. So this is x-axis means time, and this is y-axis. Y-axis can be anything depending on voltage. So here this is the peak value. So first you draw this straight line here, okay, like this. Dot dot you can draw. Okay. Dot dot you can draw. Similarly here also dot dot we can draw. Similarly for a smaller circle also you draw dot dot. And also draw for this below point. Right, like this we have drawn. Now what we need to do, first of all, draw the sinusoidal voltage diagram first. So draw that sinusoidal voltage diagram like this. We have drawn one cycle. Now how will be the current graph will look like? So current graph already we have seen, it is like I naught minus I naught cos omega t. If you remember that current equation which we have got is minus I naught cos omega t, right? This is what we have got. Okay. Hmm. See, first of all, if I draw cos graph, suppose if I draw cos graph, then it will start like this, now. You know that cos graph goes here, wherever it maximum, this become minima. Wherever this minima, that become maximum. So that means this graph will go something like this, and like this, and like this. Okay, like this it is cos graph. Okay, but we have to take minus of cos graph. Minus means just reverse this. You have to reverse this. Reverse this means what? Reverse this means start from below. From negative you start. Okay, so I will remove this graph and start from below like this, and here it should be maximum. Then here it should be minimum. Then here it should be maximum. Roughly it's like this graph. Okay, so that's the graph of the current. Okay, so this is the graph of current. This is voltage graph and this is current graph. Clear? This will come in board exam. You need to draw everything properly. And this you have to write limit. Huh. Hmm. 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 No, question means this only. Circuit diagram means they will ask like this circuit. Draw the purely resistive circuit, purely inductive circuit. 5 marks question come. So you have to start from beginning. Like you need to draw the circuit first, right? You see that circuit like this. This one. This circuit first you have to draw. Okay. Then applying Kirchhoff's voltage law, make this equation. Solve for this. Solve this equation. You have to solve. Okay. Then you write this equation. All this equation you have to write. Okay. After this, right, simplify this and bring it like this one. Okay. Of course, after this, here this point you write that, because you can clearly see from the phasor diagram that current is lagging, right? You have to note this point you have to write also. Okay. Of course, I have drawn this first this one and then that diagram. Now you write it. Okay. You may write up down, doesn't matter, but these points you have to write. Phasor diagram. The phasor diagram, we can clearly see that this angle is 90 degree below that. So you can note this point that note this point that current and voltage now they are not in phase, right? It is 90 degrees. So current is behind, voltage is ahead. So voltage phasor leads by 90 degree or pi by 2 phase angle or just pi by 2, just lead pi by 2, no problem, just leads by 90 degree. And current phasor Current user lakhs, yes, lakhs by 90 degree or 5 degree. This you have to write on derived equation. We have derived physics diagram also you have done. This graph also you have done. Then another thing I told average calculation you have to do average power. Okay. So after this is the average power, that is the last step calculation in CRT. Average power. It's integration of p dt over one cycle by total cycle. So here instantaneous power you calculate first. So power is V into I. V is V naught sine omega t. I is minus I naught cos omega t. Okay, and then you simplify that. Substitute this. So we got this as multiplication. This is okay. So V naught minus V naught I naught sine omega t cos omega t. Now divide by 2, multiply by 2. So it will become minus V naught I naught by 2. 2 sin theta cos theta becomes sin 2 theta. This is what it is. So this is the instantaneous power. Now we will use in the integration. So let us use this as integration. Integration equal. So minus V naught I naught by 2 will take outside. Then it is only sin 2 omega t dt over 0 to t divided by t. So minus V naught I naught by 2t. Sin integration becomes minus cos, right? And this 2 pi 2 omega we divide 0 to t. This minus you can take out. 2 omega also you take out. So V naught I naught 4 omega t. Put the upper limit cos of 2 omega capital T minus cos 0. Now tell me what is 2 omega t? How much it is? 4 pi means again 4 pi is also 0 only, right? So which is same as 1. So this will give us cos 4 pi. Here I am writing shortcut. So cos 4 pi minus cos 0. This will be 1 minus 1. So this term will be 0 here. This term. So because this term whole is 0, so 0 into this will give us 0. Yes. So the average power over one cycle is 0. So that's what it is. Clear? Huh? No, no, no. Tired always. I am tired only, but it does not affect my. You can give any question also. Now I am ready to solve because uh, any question I am always eager to solve. Still, I have some question to solve after this class also. One pass out senior na he has given one engineering question. That question I am going to work. He pass out, but he now he is exploring in JEE. He will go IIT. So there, I have to also tell him what books to follow, what materials. So we are also making a network of all our students who are going into IITs. They may go after few years abroad, but we are in communication contact, right? Because that is what is the relationship of teacher student, right? So it's not never tired means what physical body may get tired, but again if I am going to sleep, I will not get rest. That is the thing, because in the mind it will keep on going things. Right? Anyway, I wake up early also. I have to wake up. I get wake up early, nearly 5:30, and I then go for some jogging, almost 1 hour. Then then I come and then I go for school. I sleep around 12 o'clock. Around 12 o'clock, I take rest. So 5 hours, 5 hours is sufficient for us, but for you people, it is, I think, 6 to 7 hours sleep is required for you people. Otherwise, in the class, you will sleep, right? Okay. What time you sleep generally? What time you sleep? Mhm. Okay. Mhm. Okay, okay, fine, fine. Okay, done. So this is over. Then next we will go for this uh, purely capacitive circuit. Okay, third, purely capacitive AC circuit. But you try to find out that the constant y constant is 0. In NCRT also they have taken 0. Okay, try to find out from that NCRT. Capacitive circuit means this is a capacitor C and then it is connected with a AC voltage. This V equal to V naught sine omega t, and again same way you do, plus minus you take, current is going like this way, right? At any instant it has some charge, plus q minus q, right? So you again go in this loop and try to do that. Okay, do that. KVL, you know KVL. You can directly also write Q is equal to C into V. But why I am telling is, if there are more things, how will you do that? Okay. So go from here, this point A to B, go in this direction. A to B you go. So you are going from higher to lower voltage. The change of potential is minus Q by C, right? You know that, minus q because higher to lower, and here minus to plus, plus v is equal to 0. So from here q equal to cv, right? Q by c is v, so q equal to c. Now we want to get current, right? And voltage you substitute v naught sine omega t. Okay, so substitute now. Now you calculate current. Current I is equal to dq by dt. Differentiate. So C V naught comes out, differentiation of sine omega t with respect to t. Okay, do that. So C V naught comes out, differentiation of sine will become cos, and internal differentiation will give omega. So omega C V naught into cos omega t. That is what is current. Okay, once you got current, after that you try to write this as I naught. So this I will write this as I naught cos omega t, right? Now what is I naught here? So you can write where I naught is equal to omega c V naught, and this can be written as V naught divided by 1 by omega c, correct? Right? Because this omega c comes in numerator, right? So, but this term 1 by omega c is called xc, just like resistance, voltage by resistance. So, that is why this term xc is coming here, which is called 1 by omega c, and this term is called capacitive uh, reactance, capacitive reactance, okay? Capacitive reactance. So, that's what it is. Now again this is coming cos, now we have to bring in sine, okay? Bring in sine. So this now you can write as sine 90 plus or omega t plus 90, correct? Omega t plus 90, that's what it is. So current we can write it like this, or you can keep current like this, it doesn't matter, it's the same thing. But we write because we have to compare with voltage, which is also in terms of sine, okay? So now you draw the phasor diagram. And also note, I think phasor diagram you can do and then note, that is better, because from phasor diagram everything is clear. Okay. So phasor diagram you draw, this is voltage signal, this is your omega t, right? And now current has to go like this way, current I naught, this angle will be 90 degree. So from this action, this is omega t plus 90 degree. Okay, so you can draw a circle also. Again, as I told you, can draw this circle also for drawing this circle, and you can draw the bigger circle for the voltage also. Draw the phasor diagram like this. Now here when you draw the graph, this is T and this is Y, correct? So then you take this voltage graph first. So voltage graph again dot 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 dot, it will lie between these two lines, right? Voltage. To draw this graph, sine graph is like this. Okay, sine graph is like this. Then what about this? And this is anyway cos graph, right? Cos graph is easy to plot. Let us plot that cos graph. And here the maximum value is this, and here below minimum value is this. So in between this it will lie. In between this it will lie. So let us draw cos graph means it will start here, then here, then it will come here, then here, then here. So draw that like this. Over. That's what is cos graph. So this is current graph and this is voltage graph. Let's see. Now again here also you can calculate the average power. Average power, how will you calculate? Before that, write down this point. Okay, note that current here, current leads, right? Current leads by 90 degree, and voltage lags by 90 degree. Correct. Then you calculate instantaneous power. P is equal to what? P is equal to V into I. V is V naught sin omega t, and current is I naught cos omega t. So similar term is going to come, right? Huh? V naught I naught sin omega t cos omega t. So what do you get now? Again divide by 2, correct? So sin 2 omega t, correct? Instantaneous you got, now you calculate average by the same method. So average power is same integration p dt 0 to t t 0 to t, power is v naught I naught by 2 sin 2 omega t dt divided by total time. Again you do the integration in the same manner. So what will happen? V naught I naught by 2t comes out, sine integration. Sine integration you know again, minus cos, right? 2 omega t by 2 omega. Now put the limits 0 to t. So V naught I naught by 2t, if you want minus take out, omega also there, 2 omega keep it. Then cos of again 4 pi will come, correct? Minus cos 0, correct? Right? Okay. Again it is going to 0 also. Again 0. So average power is going to be again 0. These are the three fundamental circuits, because if you have understood this fully, then further it will be very helpful in developing complex circuits. Because all the questions you will solve using phasor diagram, you cannot solve using differential equation, because that is also not there in JEE syllabus. Okay. Second order differential equations which will come in NCR circuits. Clear? Yes. So next means Saturday we have, right? Saturday. So Saturday we will solve problems on this, and also the LCR circuit we will finish, and then resonance finish. Two things it will finish. Then we can solve problem. Then most of the things are done. Okay. So are you solving problems or not? We are working out. No, no problem. Don't worry. It's okay. But the thing is that you keep on keep on reading, means books also you have to read NCRT. because for NEET NCERT is a key book, right? Most of the things is coming from NCERT. I am planning to launch one NCERT series. Already I had started the first chapter. If you see my videos, I have started for this motion in a straight line full NCERT solution. I have made in detail. It is 4 5 hours. Full NCERT chapter, old NCERT, including all the tough question and example also. Only thing which I have not done is example long question. That also I will do. It will take extra 1 hour, 2 hours like that. I plan to do that, but it is quite lengthy. And NCERT book I find is really very interesting. So many things are there, but generally they are not teaching or they are just skipping that. But lot of in depth is there in NCERT. That is why NTA are choosing NCERT only now, because so much in depth is there. Correct. So we have to really work more. NCERT we cannot ignore. So solve NCERT questions, right? And once topic is over, we can work out example question also. In our app, we have uploaded the NCERT old book as well as NCERT exemplar. That will be very much beneficial. Correct. Okay. So that will be done. So then we will see next. Hmm? Okay. So then we will see tomorrow. Fine. Means day after tomorrow also we have 11. 11th. Okay, we will see that tomorrow. Okay then. Yeah. Bye bye. Yes. Good night. Hmm.